Just a few miles west of Loveland, Colorado, something unusual began happening in 2021. Entire stretches of forest were cleared, the earth was blasted open, and trucks hauled away thousands of tons of rock and clay. To anyone watching, the activity must have raised questions. What on earth is going on? The short answer? They're planning to flood the area. On purpose. But not before they build one of the largest dams in Colorado. Right here, in the middle of the forest. And this dam won't just be any dam. Once completed, it will become the second largest asphalt-core dam in the entire United States. But that raises another question. Why build such a massive dam out here? Why clear forests and move mountains for a project that seems so remote? To understand, we need to go back in time, way back to the 1960s. Back then, 6 growing cities, Boulder, Estes Park, Fort Collins, Greeley, Longmont, and Loveland, decided to secure their future water supply. Their solution? Create an organization dedicated to managing water from the Colorado River. This became known as the Northern Water Municipal Subdistrict. Their first major initiative was the Windy Gap Project, launched in 1985 after more than a decade of planning and construction. Its mission? To divert and store water from the Colorado River for municipal use across the Front Range. The project worked like this. Water from the Colorado River was collected in the Windy Gap Reservoir, then pumped through a nearly 6-mile pipeline to Lake Granby, a massive man-made lake created back in 1949. But this setup wasn't perfect. Windy Gap Reservoir is tiny compared to Lake Granby. We're talking 145 million gallons versus 174 billion gallons. That's like comparing a swimming pool to the Pacific Ocean. So, Windy Gap was never meant to store large amounts of water, just collect and transfer it. Lake Granby became the region's main water hub, distributing water through Shadow Mountain Reservoir, Grand Lake, and beyond. But there was a problem. Lake Granby is already part of the larger Colorado Big Thompson Project, or CBT. When heavy rain hits or snowmelt surges, Granby fills up quickly, sometimes before it can accept any water from Windy Gap. And since Windy Gap can't store much, any overflow simply goes to waste. That's a big issue. Windy Gap is supposed to supply nearly 16 billion gallons of water every year. Losing even part of that can mean shortages down the line. One possible solution? Carter Lake, another reservoir east of the mountains near Loveland, which is already part of the CBT distribution system. With a 36 billion gallon capacity and a hydropower plant on site, Carter Lake sounds like a great candidate. But there's a catch. It's already at capacity. So Northern Water had to come up with a new plan. One that would ensure a reliable water supply for the future, especially with Colorado's population booming. Their solution? Build a brand new reservoir and dam just west of Carter Lake. Enter the Chimney Hollow Reservoir Project. This isn't just a water storage facility. It's a monumental engineering project designed to secure water for over 825,000 people. When complete, Chimney Hollow will hold 29 billion gallons and provide up to 10 million gallons per day to nearby cities. Let's talk about the dam. Chimney Hollow Dam will stand 347 feet tall, making it the 3rd tallest dam in Colorado and one of the highest in the Front Range. But what makes it truly unique is its construction. It's being built with an asphalt concrete core, a rare method in the United States. Why asphalt? There are a few big reasons. First, it's highly impermeable, which is crucial when you're trying to hold back billions of gallons of water. Second, it's flexible. Unlike traditional dams, asphalt-core dams can move slightly with shifts in the ground. That's especially helpful in seismically active areas, like parts of Colorado. And third, it's cost-effective in this specific case. The valley where Chimney Hollow is being built lacks enough natural fine clay, which is typically used in earthen dams. Transporting clay from elsewhere would have been expensive. Using asphalt concrete allowed engineers to build on-site more efficiently. So what's been done so far? First came the plinth, a solid base that connects the dam's asphalt core to the rock below. Thousands of steel anchors secure it to the bedrock. Next, crews drilled over 2,000 boreholes, measuring underground geology and injecting a special grout to seal cracks and prevent leaks. Then came the asphalt, The dam's core used 2 million cubic feet of asphalt concrete, surrounded by 317 million cubic feet of rock, all sourced directly from the valley itself. That's a massive amount of material, requiring around 500 workers on site daily during peak construction. But that wasn't all. A second, smaller southern dam had to be built too, though only 39 feet high. It still required 2.6 million cubic feet of stone and 82,000 cubic feet of clay to help contain the reservoir from all directions. With the dams in place, the project moved on to key infrastructure. That includes the spillway, a mile-long channel made of 176,000 cubic feet of concrete to handle overflow and prevent flooding. Engineers also constructed the inlet and outlet works, connecting the reservoir to the broader water supply system through pipelines and tunnels. The total cost of the project, $535 million. Surprisingly, the budget hasn't changed, and construction is on track to finish by the end of 2025, a rarity in large-scale infrastructure projects. But there's another question. What about the environment? Northern Water hasn't shared much about the ecological impact of flooding a forested valley, but past experience tells us it's not always smooth sailing. Take the Windy Gap Reservoir, for example. Despite its small size, it caused serious damage to the Colorado River ecosystem. By disrupting the river's natural flow in 1985, it eliminated seasonal surges that helped clean sediment from stream beds. This destroyed habitat for insects and macroinvertebrates, disrupting the food chain. The goby fish, an indicator of river health, disappeared completely. Local trout populations suffered from disease, and biodiversity dropped by 38% between the early 80s and 2011. Only in 2022, 37 years later, did Northern Water take action with the Colorado River Connectivity Channel project. They have the size of Windy Gap Reservoir and built a new channel to allow the river to flow more naturally around it. This included removing an upstream dam and adding a diversion structure to better regulate water flow. By 2024, water had been flowing through the new channel for over 6 months, slowly restoring the ecosystem. So, with that history in mind, many are watching Chimney Hollow closely. Will this new reservoir lead to similar environmental consequences? Or has Northern Water learned from the past? For now, the focus is on completing construction. Soon, the valley will be transformed into a massive lake, fed by the Colorado River and designed to meet the growing water demands of northern Colorado. Whether this project becomes a model for smart infrastructure or another ecological cautionary tale remains to be seen. But one thing is certain. Chimney Hollow Reservoir is one of the most ambitious and technically unique water projects in the U.S. today, and it could shape Colorado's water future for generations to come.
Throughout American history, the pursuit of ambitious infrastructure has shaped not just skylines and highways, but the nation's very identity. From the Transcontinental Railroad of the 19th century, which stitched together a vast and varied landscape, to the interstate highway system of the mid-20th century, the United States has long demonstrated a collective will to tackle large-scale projects with transformative potential. Indeed, some of the world's most iconic feats of engineering, such as the Hoover Dam or the Golden Gate Bridge, stand as testaments to a national spirit that values innovation, progress, and connectivity. Today, in the year 2025, that tradition continues with a new wave of mega-projects nearing completion across the country, each promising to leave its mark on infrastructure, technology, and economic development. These projects, ranging from massive bridges to semiconductor fabrication plants, reflect not only America's commitment to modernizing its built environment, but also underscore the evolving demands of a global economy. At a time when supply chains are being reimagined and sustainability is at the forefront of public discourse, these ventures converge engineering expertise with strategic foresight. The Gordie Howe International Bridge. On the banks of the Detroit River, the aging Ambassador Bridge has for decades handled a vital flow of commerce between the United States and Canada. Since its opening in 1929, it has facilitated one of the highest volumes of international truck traffic in North America. However, by the early 2000s, swelling trade and mounting congestion highlighted the need for a second crossing. discussions between the Canadian and U.S. governments eventually culminated in plans for a new bridge named after Canadian hockey legend Gordie Howe. Fast forward to 2025, and the Gordie Howe International Bridge is approaching its final stages of construction. Spanning approximately 2.5 kilometers of the Detroit River, the bridge features a modern cable-stayed design with towering pylons that frame the waterway on both sides. While the original timeline targeted completion by late 2024, supply chain disruptions for steel and specialized cables extended the schedule. Nevertheless, project managers report that over 90% of the construction work has now been completed, with traffic expected to flow before the end of this year. In total, the bridge and its associated ports of entry represent an investment of over $5.7 billion. This includes state-of-the-art customs facilities and dedicated lanes to streamline the crossing of commercial trucks, personal vehicles, and pedestrians. Once operational, estimates suggest it will reduce wait times by up to 50% during peak hours. Beyond reducing congestion, the project promises expanded trade capacity between two of the world's largest trading partners. Supporters tout the economic benefits, projecting an increase in cross-border commerce that could exceed $100 billion annually by 2035. Not everyone has embraced the project without reservation, however. Local communities in southwest Detroit raised concerns about air quality and traffic disruptions during the multi-year construction phase. Environmental impact statements highlighted the potential for increased noise and pollution in nearby neighborhoods. In response, the binational project team instituted community benefits funds, offering grants for local green spaces, job training, and small business support. These measures aim to ensure that while international trade thrives, local residents also share in the economic gains. TSMC Arizona Fab. Semiconductors are often referred to as the brains behind modern electronics, powering everything from smartphones to electric vehicles. Since the early 2020s, global chip shortages have underscored the vulnerability of foreign-dominated supply chains. In response, the U.S. government passed legislation to incentivize domestic production, culminating in large-scale projects under the umbrella of the CHIPS and Science Act. Leading this charge is Taiwan's semiconductor manufacturing company, known as TSMC. In North Phoenix, Arizona, TSMC broke ground in 2021 on a multi-billion-dollar fabrication facility intended to produce advanced chips using 5-nanometer and 4-nanometer processes. Original projections targeted 2024 for full operation, but a shortage of specialized construction labor and delayed equipment shipments pushed the operational date to late 2025. Despite these setbacks, the project is now in its final fit-out phase, with mechanical and electrical systems being rigorously tested. The facility, estimated to cost $12 billion initially, has grown in scale to over $40 billion as TSMC announced further expansions. Proponents argue that domestic chip production will bolster national security and reduce reliance on East Asian manufacturing. This plant alone is projected to create upwards of 2,000 direct jobs, including high-tech engineering roles, while spurring thousands more in peripheral industries. Critics, however, caution that the learning curve for workforce training remains steep, given how specialized semiconductor manufacturing has become overseas. Still, TSMC has formed partnerships with local universities, offering scholarships and advanced training programs to cultivate a talent pipeline. Samsung Semiconductor Plant in Taylor, Texas. About 1,000 miles to the east in Taylor, Texas, Samsung is also making headlines with its $17 billion semiconductor factory. Located just outside Austin, this facility will focus on producing chips for consumer electronics, automotive systems, and artificial intelligence applications. Ground was broken in 2022, and despite early concerns about water consumption in a region that frequently grapples with drought, developers implemented advanced water recycling infrastructure. As of 2025, Samsung reports that the plant is roughly 80% complete. Structural, electrical, and ventilation installations have begun, and a workforce of approximately 3,500 construction personnel is on-site daily. Officials project that initial chip production could commence in mid to late 2025, aligning with the intensifying global demand for microcontrollers and processors. Once online, the facility is set to become one of the largest of its kind in the United States. Local communities are optimistic about job creation and the potential for spin-off businesses, while environmental advocates point to the factory's reclaimed water systems as a model of sustainable industrial development. The LA Metro D Purple Line Extension. Shifting gears to public transit, Los Angeles, a city synonymous with cars and congested freeways, continues its ambitious expansion of the Metropolitan Transportation Authority, Metro rail system. Since the 1990s, LA has worked steadily to reshape its reliance on cars through the development of subway and light rail routes. The Purple Line, now officially called the D Line, runs along Wilshire Boulevard, one of the most heavily traveled corridors in the county. The construction process has not been without challenges. Tunneling beneath dense urban neighborhoods introduced technical complexities, including geological surprises and traffic detours that impacted local businesses. Yet the community outreach efforts, combined with the promise of reduced congestion and lower carbon emissions, have largely supported the project's momentum. City planners see it as a cornerstone of LA's sustainability goals, anticipating a surge in public transit ridership that could reshape commuting patterns in one of the nation's most car-centric regions. The new J.P. Morgan Chase headquarters at 270 Park Avenue. In Manhattan, skyscrapers are more than just office spaces. They are symbols of global finance and architectural ambition. In the wake of changing work patterns, where remote and hybrid arrangements have become increasingly common, J.P. Morgan Chase broke ground on a new state-of-the-art headquarters that aims to define the future of high-rise office buildings. Located at 270 Park Avenue, the new tower replaces the old 52-story Union Carbide building, once the headquarters for Chase. Demolition of that structure concluded in 2021, making way for a planned skyscraper rising to approximately 1,388 feet. By 2025, the steel superstructure has topped out, and workers are installing the final sections of the exterior glass curtain wall. The projected cost stands at around $3 billion. Central to the building's design are advanced sustainability measures. J.P. Morgan Chase has publicly committed to achieving net zero operational emissions in the tower, powered in part by on-site solar installations and an innovative energy storage system in the basement. According to city officials, this will be one of New York's largest private sector contributions to greening the skyline. With an anticipated workforce capacity of 12,000 employees, the tower's interior features flexible floor plans, cutting-edge air filtration, and communal spaces designed for collaboration. While questions remain about the evolving nature of in-office work, the sheer scale and technological sophistication of 270 Park Avenue are widely seen as setting new benchmarks for commercial real estate in the city. LAX modernization. Los Angeles International Airport, commonly known as LAX, has long ranked among the world's busiest airports. Over the last decade, the airport has undergone a massive modernization program aimed at improving passenger experience and reducing congestion. Key components include terminal refurbishments, roadway enhancements, and the development of an automated people mover APM system to link travelers more seamlessly to public transportation and rental car facilities. As of 2025, the APM, a system of elevated guideways and stations, has completed final testing and is on schedule to welcome passengers by the end of the year. The budget for the APM alone exceeds $2 billion, with modern driverless train cars expected to operate 24 hours a day. Airport officials anticipate that this infrastructure will cut curbside traffic by up to 15%, a significant relief in one of the nation's most traffic-prone cities. Future projects include preparing for the 2028 Summer Olympics, where LAX's new capabilities will be put to the test, accommodating millions of visitors over a short period. Buffalo Bills new stadium. In western New York, construction of the new Buffalo Bills Stadium in Orchard Park has captured the attention of sports fans and civic leaders alike. Estimated at over $1.4 billion, the open-air stadium began rising in 2023 and is slated for completion ahead of the 2026 NFL season. Although the grand opening is still a year away, 2025 is significant for reaching key structural and roofing milestones. By late this year, nearly all of the concrete and steel framework should be in place, with the next phase focusing on seating installation and advanced sports technology integrations. The facility's design prioritizes fan experience and aims to reflect the region's heritage, from local food offerings to architectural elements inspired by Buffalo's historic building styles. Renewable energy megafarms. Amid shifting energy policies, large-scale solar and wind projects have gained traction. In the Southwest, where arid conditions and prolonged sunlight prevail, vast solar farms are nearing completion. Many of these projects feature cutting-edge photovoltaics with battery storage systems, allowing for a more consistent energy supply. By 2025, states like Arizona and Nevada are bringing online solar farms that collectively add over 5 gigawatts of capacity to regional grids. In the Midwest, wind farms continue to expand, employing taller turbines capable of capturing higher altitude wind streams. The United States now ranks second worldwide in total wind power capacity, and these new installations stand to push the nation even closer to the global leader, China. For communities hosting these wind farms, the influx of property tax revenue and lease payments to landowners represent a significant economic boost, although concerns about visual impact and noise persist. Nonetheless, developers emphasize that these megafarms will play a critical role in meeting renewable portfolio standards set by various state governments. As the United States stands at this pivotal moment in 2025, the nearly completed array of megaprojects underscores a nation intent on reinventing itself for the 21st century. Even as these projects are near completion, the real test lies in how effectively they deliver on their promises, whether that means alleviating traffic congestion, stabilizing microchip supply chains, or reducing carbon footprints. Their progress will offer valuable lessons in planning, funding, and operational best practices, lessons that could shape the next generation of American infrastructure. And with each ribbon cutting, ground opening, or newly humming assembly line, the United States signals not just the end of one grand phase, but the beginning of another. In the coming years, the ripple effects of today's endeavors will continue to unfold, forging pathways for tomorrow's innovators, builders, and communities. Ultimately, the projects of 2025 stand as a testament to a nation's resolve to keep pushing forward, ever reaching, ever building, and ever envisioning what might lie just beyond the horizon.